5.2 area. We're going to start off with sigma notation. Some of you might be familiar with this, some of you might not. We're going to use this quite a bit for this lesson, so let's review it. Sigma notation, the sum of n terms. So if we were going to add up this term plus this term plus this term plus n number of terms, where this would be the first term, this would be the second term, this would be the third term, this would be the nth term, is written by this Greek symbol here means the summation. So the summation beginning when I is 1 to the nth term of a sub I. So you would do, starting with 1, you would do a sub 1, a sub 2, a sub 3, and you would keep going until you would get to the nth term. N could be any number. I is the index of the summation, a sub I is the nth term of the sum, and the upper and lower bounds of summation are known as n and 1. So the upper bound would be n, the lower bound would be 1. Okay, so let's practice some of these so you can see how they work. So the summation from 1 to 6 of I. So when I is 1, you're going to have 1. When I is 2, you'll have 2. When I is 3, you have 3. I is 4, you'll have 4. I is 5, you'll have 5. And then finally, the last term, when I is 6, you'll have 6. So then we would just add these together. This would be 7. This would be 7. This would be 7. So this is going to be 21. Let's look at the next example. This time, the lower bound is 0 and it goes to 5. So the first term, you would plug in 0 plus 1. The next term, you would do 1 plus 1. The next term, you would do 1 plus 2. The next term, we would do, you would do 2 plus 1. Then you would do 3 plus 1. Then you would do 4 plus 1. And then finally, we would do 5 plus 1. So we're going to end up getting 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is just like the previous problem, which would be 21. All right, let's look at the next one. So now we got some different variables in here. This time, instead of calling this I, we're calling it k. So it's starting with k, ending with n. So the first term, you're going to plug in 1 for k. We don't know what n is, so we'll just keep that 1 over n. Then it would be 1 squared. So this would be 1 plus 1. The second term, it would be 1 over n. It would be 2 squared, so it's going to be 4 plus 1. The next one, you're going to do 3. So it's going to be 1 over n. 3 squared would be 9 plus 1. And then we could continue this on forever, but I'm going to do plus dot dot dot. And then I'm going to go to the nth term. So I'm going to do 1 over n. And then it's going to be n squared plus 1. Okay? So now we can simplify this a little bit. So notice here, each one of these terms in the beginning here, we have 1 over n. So I'm going to factor that out in front. And then I'm going to simplify each of these. So this would be 2 plus 5 plus 9 plus dot 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 plus n squared plus 1. And then we could simplify this some more, making this 1 over n. This would be 7 plus 9, which would be, let's just leave it like this because we got all these terms in between here. So we don't really know. That would be as much as we'd want to simplify that one. Alright, let's look at f. F, we've got the sum from 1 to n of f of x sub I delta x. So first of all, when I is 1, we're going to have f of x sub 1 delta x. When I is 2, we're going to have f of x sub 2 delta x. When I is 3, we're going to have f of x sub 3 times delta x plus dot dot dot. That's just going to continue on. And then eventually f of x when I is n, the nth term, would be x sub n delta x. Again, for this one, you can see that there is a delta x in all of these. So we can factor out delta x, and then we can write the sum f of x sub 1, f of x sub 2, f of x sub 3, plus dot 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 f of x sub n. Let's look at a few properties here. So here, if we have the summation from when I is equal to 1 to n of k times a sub I, where k is a constant, what you can do, you can factor the k out in front. So then when you do the summation, it would be I, and then it would be a sub 1, a sub 2, a sub 3, plus dot dot dot, plus a sub n. Look at number 2. If you have the summation from 1 to n of a sub I plus or minus b sub I, we can break this up and write it as two separate summations here. Okay, some summation formulas that I want you to memorize here. We're going to use these. If you have the summation from 1 to n of c, where c is a constant, the summation here is going to be c times n. So let me give you an example here. Let's say you had the summation I equals 1 to n, and let's say the constant is 5. And let's say n, let's define n as being 4. So the rule says take the constant, which is 5, multiply it by n, which is 4. This should be 20. Okay? The other thing that you could have done, when I is 1, you're going to have 5. I is 2, you're going to have 5. I is 3, you're going to have 5. I is 4, you're going to have 5. 5 plus 5 plus 5 plus 5 is 20. So that's a nice little shortcut. Alright, let's do another one. Let's say we have the summation from 1 to n of I. The shortcut here would be n times n plus 1 over 2. So again, let me give you an example here. Let's do the summation from 1 to 3 I. It says that would be equal to n, which is 3, times 3 plus 1 all over 2. So this would be 3 times 4 divided by 2. So this would end up being 6. And let's look at why this would be true. If you did this one when I is 1, this would be 1. I is 2. This would be 2. When I is 3, this would be 3. So this would be 6. So memorize these, because if this wasn't 3, if this was 50, okay, that's the sum of the first 50 numbers. It's going to be much easier if you use the shortcut method than it would be to add that up, all 50 of those numbers. So let's try one of these. Let's try this one. Evaluate the summation, where we've got I is equal to 1, okay, to the nth term, I plus 1 all over n squared, or when n is 10, n is 100, n is 1,000, n is 10,000. So first of all, let's just solve it in this form, and then we'll plug in the different values for n. So first of all, I can rewrite this. I can factor out 1 over n squared out in front. The summation, I is 1 to n of I plus 1. And then I can write this as 1 over n squared. The summation, I equals 1n. This will be I plus the summation, I equals 1 to n of 1. Now we know that this right here, let's do 1 over n squared, that's going to be equal to n times n plus 1 all over 2. And this would be, this is c times n, so this would be 1 times n, that's going to be n. And then we can simplify this. If we multiply n squared in the denominator all the way through, this n would cancel out, so then you're going to have n plus 1 all over 2n, and this n would cancel out, leaving us with 1 over n. And now we can solve for each of these summations. So notice, when n equals 10, this would be 10 plus 1 all over 2 times 10 plus 1 over 10, which would be 11 over 20 plus 1 10, or 2 over 20, which would be 13 over 20. I think you could find the rest of these. Just next, take this formula, plug in when n is 100, and so on and so on.